Hi, in this problem we're going to look at what is happening when we charge a capacitor. More in detail, we're actually interested in the voltage on the capacitor that we have down here after 2 minutes of charging when we charge with an uncharged capacitor. So the moment we close this switch here at t equals 0, the capacitor will start charging, and we want to know what is the voltage across it at 2 minutes. You should remember the formula for the voltage across the capacitor, which is Vc as a function of time is the maximum voltage times 1 minus e to the power of negative t over Rc. So the main question here actually is what is Vmax. You might recall that if we will plot this function with Vc on the y-axis and time on the t-axis, you get something around this. We start from 0 and we approach Vmax. Well, Vmax, of course, is when the capacitor is fully charged. So let's redraw our circuit with the switch closed and C fully charged. When C is fully charged, there's no more current going on the capacitor, so it behaves like an open switch. And if you would do a loop rule, what we would get is plus the EMF across the battery minus the resistance times the current minus Vc is 0. Now, of course, if we have an open switch here, the current is 0. Therefore, we get Vc, which is in this case Vmax, is equal to the EMF, which is 6 volts. Now, all we have to do is plug that in our equation. So we have Vc at t equals 120 seconds. I always make sure to convert it into SI standard units, is 6 volts times 1 minus e to the negative 120 seconds divided by 80 kilo ohms times 1000 microfarad. And now let's use our calculator for that. Okay, so we have 6 volts times 1 minus e to the negative 120 over 80 kilo ohms. 8, 1, 2, 3 times, what's the capacitance again? The capacitance was 1000 times 10 to the negative 6 microfarad. Let's see what that gives. 4.66 volts. The result 4.66. We can finally check if this result makes sense. If you recall, we had a V of 6 volts, Vmax of 6 volts, so we get here Vmax of 6 volts. So 4.6 is somewhere here. So this is one of the possible answers. If you ever get something higher than 6 volts, you do know that you made a mistake. But here we get something that's lower, so we could write at t equals 120 seconds is my 4.66 volts. And that's it.